Our research contribution is rotational symmetry field design on surfaces. A rotational symmetry field is a field that is invariant under certain rotations. This 4-symmetry field, or 4-Rho-C field, is invariant under rotations of 90 degrees. Among other types of Rho-C fields are 3-symmetry and 6-symmetry. One of our key contributions is the ability to represent an n-Rho-C field with a representational vector field. For example, this 4-symmetry field can be represented by this vector field. Consequently, summations and scalar multiplications can be performed on the vector field, thus avoiding complications caused by the directional ambiguity in the n-Rho-C fields. N-Rho-C fields have a variety of applications, two of which include non-photorealistic rendering and remeshing. Here we show two pen and ink renderings of the Venus model. The streamlines in the image on the left were taken from the curvature tensor. Note their more turbulent nature and the more irregular field. The image on the right was generated by smoothing the curvature tensor as a 4-Rho-C field. Here the streamlines follow a more regular grid-like pattern. N-Rho-C fields also have applications in remeshing. Here, this 4-Rho-C field on the bunny, derived from the curvature tensor, is used to generate a quadrangular mesh of the surface. We also anticipate the use of 6-Rho-Cs in triangular remeshing. Note how closely these 6-symmetry streamlines traced on the dragon resemble a very regular triangulation. Here we demonstrate our system's design capabilities in the plane. We start by creating a positive singularity in a 4-Rho-C field. Note that this point has 3 overlapping hyperbolic sectors, here, here, and here. On each border between 2 adjacent sectors, our system correctly detects and traces a separatrix. We can further modify the field by rotating our created singularity. We can also move existing elements and also create new singularities which blend naturally with the existing field. Note that unspecified singularities will occur as a result of singularities specified by the user. In addition to the creation of new fields, our system can also perform editing operations on existing fields using region growing and optimization techniques. Here we modify a 3-symmetry field by first canceling a pair of positive and negative singularities. We then move the remaining positive singularity into the center of the field. Here we demonstrate our system's design capabilities on surfaces. In this demonstration, the user designs a simple 4-Rho-C field on the sphere that resembles a cube. This field also illustrates how rotational symmetries appear naturally in Platonic solids. Finally, we wish to show how the previously described editing techniques can be applied to pen and ink rendering. Here, we have such a rendering of the Venus model, and yet there are artifacts on the chest and under the armpit. More careful examination of these artifacts reveals that they are the result of nearby singularities in the underlying field. We would like to cancel these two and move this one to a less conspicuous location. However, if we attempt to do this with global smoothing, the pair we wish to cancel actually move apart from each other, and we have little control over the movement operation as well. Going back to the original field, we use our editing techniques to cancel the first pair and move the third into the armpit, where its effects are less conspicuous. Once the movement is finished, we perform a very small amount of global smoothing, just to remove irregularities in the field and achieve more visually pleasing hatches. We now have our final result, which has much fewer irregularities than the original.